Hey everyone, welcome into Unit 6, Day 1. This is the first day of our last unit of notes before our final exams. So, almost at that celebration time, we need to finish strong here in this last unit. And on this first day, our focus will be that students will be able to isolate and solve equations with absolute values with 80% accuracy. So our focus is going to be on absolute value. And the first thing we need to make sure we are all on the same page about is what absolute value is. Well, absolute value is the distance a number is from zero. Distance can't be negative. So when we're doing the absolute value of something, we're talking about distance. -3 is 3 away from zero. It's always going to be positive because distance can't be negative. So that is what absolute value is. And now let's go into the steps we are going to use to solve equations with absolute value in them. So step 1, we want to isolate the absolute value bars. So the absolute value bars look like that. They are just two vertical bars that they're kind of like parentheses, but they're just vertical bars to help distinguish between them. And we want to isolate that. Just like we've been isolating variables this whole time, we want to isolate the absolute value bars or get that all by itself on one side of the equal sign. Step 2, when the absolute value bars are isolated, we are going to split into two equations, two situations, and we're going to solve them both. Okay? So once we split, add this in, we are going to drop the absolute value bars from the equation. So we're going to split the equations, we're going to drop the absolute value bars, and in the first equation we're going to create, and we're going to set the equation, whatever's inside the absolute value bars, we're going to set it equal to the positive version of what's on the opposite side of the equal sign. And the second situation is we are going to set that information equal to a negative version of what's on the opposite side of the equal sign. And then after that, we are going to solve for x in each equation. And we're going to get two answers. So we should end with two answers. Okay, so let's go ahead and take a look at some examples. So in example number 1, we have the absolute value of x minus 4 equals 10. So the absolute value bars are isolated. They are all by themselves. So once they are all by themselves, we are going to split into two equations. We're going to drop the absolute value bar. So we just have x minus 4. And we're going to set it equal to the positive number, which is positive 10. And then we're going to do a separate equation, a second situation, just like we put in step B here. We're going to set it equal to the negative version of that number. So we have x minus 4 equals negative 10. And actually, let's highlight that for our notes. We're setting it equal to the negative. So that's the difference between the two. Everything is the same except one of them has a positive 10 and one of them has a negative 10. And then we just solve both of these like normal, right? So we're going to add 4 to both sides. X equals 14. Add 4 to both sides. And we get x equals negative 6. Okay? All right, let's take a look at example number 2. In example number 2, the absolute value bars are not isolated. We have a 3 next to, which means it's being multiplied. Right, so that's 3 times the absolute value of x minus 3 equals 12. So before we can split, we need to get the absolute value bars isolated by getting rid of that 3. We get rid of the 3 just like we would if it was 3x, right? To get rid of that, we would divide by 3. And so it's the same deal. When next to means multiply, we do the opposite to get rid of it. So that cancels out, and we're left with the absolute value of x minus 3 equals 4. Now the absolute value bars are isolated, and we can split into our two equations. So we have x minus 3 equals 4. So everything stays the same because we have a positive. And now we're going to write x minus 3 equals, and it's going to be negative 4, right? That's the one shift. The first equation has a positive 4. The second equation has a negative 4. And then we solve these like normal. So we add 3 to both sides. X equals 7. Add 3 to both sides. X equals negative 1. All right, let's take a look at the next example, example number 3. Okay, so we have to isolate the absolute value bars. So the first thing we have to do is, just like in any other equation, we do the subtraction or addition before we do the division or multiplication. So we have to subtract this 5 from both sides. We get negative 2 times the absolute value of 3x plus 3 equals negative 18. Okay, and then we still have one more step before the absolute value bars are completely isolated. We have to divide by this negative 2 on both sides. And we are left with the absolute value of 3x plus 3 equals positive 9. Now we can split because the absolute value bars are isolated. So 3x plus 3 equals 9. And then we have 3x plus 3 equals, and now it's a negative 9 over here. And now we just solve both of these. So we subtract the 3 from both sides. We're left with 3x equals 6. Divide by 3. X equals 2. And then same deal over here. 3x equals negative 12 divided by 3. X equals negative 4. Okay. All right. Give number 4 a try and come back, and we'll see how you did. See you in a few seconds. All right. Welcome back. Take a look at your answers. I got x equals 4 and x equals negative 3. So check through your work. If you did something incorrect, right, go through all the steps, see if your steps match my steps. Make sure you set the second equation equal to a negative 14. That could be a common mistake. And if you got everything correct, awesome. If not, make sure you're double checking, and then we'll go on to example number 6. We're going to skip 5, go to 6 right now. So for number 6, we have the absolute values on the right side of the equation, and that doesn't change anything. We still go through the same process. We want to isolate the absolute value. So we're going to add 6 to both sides. That gives us 2 absolute value of x minus 5. We're going to go ahead and split. So we have 2 equals x minus 5. And we have negative 2 equals x minus 5. So same exact process. It's just a little bit different because the absolute value is on the right. And you could shift everything around if you want and you prefer the absolute value being on the left side because that's what you're used to. That's totally fine, but it is not necessary. All right, we get x equals 7. And we get x equals 3. Okay. All right, let's take a look at another different example. Example like number 7. I'm going to rewrite this to give us a little bit more space to work with. Okay, so whenever we have the entire side of an equation on top of a fraction or above another number, we want to get rid of that denominator. The way we do that is by multiplying by that denominator. Those cancel out, and we are now left with 3 times the absolute value of x minus 4, and then we have the 2 times 15, which is 30. Now we divide by 3. This looks more familiar to us. X minus 4 equals 10. Now we split. X minus 4 equals 10. And x minus 4 equals negative 10. So we're going to add the 4. X equals 14. Add 4. X equals negative 6. Okay. And the last one we're going to talk about is number 9. So for number 9, again, I'm going to rewrite to give myself a little bit more space to work with. Okay, so to get rid of a fraction, we want to multiply by the denominator. So same deal. Those cancel out. We're left with x minus 6. And then those 5s cancel out as well. And when those cancel out, we're just left with the 4. And now we can split. X minus 6 equals 4. And x minus 6 equals negative 4. Okay. So now we go ahead and solve. We add 6 to both sides. X equals 10. Add 6 to both sides. And we get 2. And there's our final answer. Okay. Go ahead, take a few moments to pause and try the 3 problems we did not do on this side, and then come back and check your answers. Okay, see you in a few. Okay, let's go ahead and check out the answers. So for problem number 5, our answers are x equals 2 and x equals negative 2. Again, the common mistake that we see is people forgetting to switch that second answer to a negative, so making that negative 10. Number 8, the answers are x equals 14 and x equals 0. The one thing I want to point out is that we can combine like terms here. Negative 5 and negative 12 makes negative 17, which then we could add. And if you added 5 and then added 12 separately, that does work. But combining like terms gives us that negative 17, and then we can add that 17 all at once. And then if we take a look at number 10, the answer number 10 is x equals 8 and x equals negative 4. And again, there are decimals, but we go through the same process. You isolate the absolute value, and then once that's isolated, you split and make the second answer a negative, and then you go ahead and finish solving. Okay, great job on this day 1 of the final unit of the semester. If you have any questions, make sure you reach out to your teacher. Go back and check your answers through this a little bit more thoroughly. If not, we appreciate you stopping by, and have a great day. Peace out.